Good morning. My name is Gaurav Simrata. My roll number is 209511223. My branch is Information Technology. Today we are going to discuss a concept real-time system. So what is real-time? So real-time systems are defined as those systems in which the correctness of the system depends not only on the logical result of the computation but also on the time at which the results are produced. A real-time system has performance deadlines on its computations and actions. Deadlines: time when execution must be complete. A deadline is either a point in a time or a delta time interval by which system action must occur. Hard deadline: late data may be a bad data. Soft deadline: late data may be a good data. Hard real-time system example are ionic control from real-time system are banking, soft real-time system or video on demand. So applications of real-time system are industrial applications, chemical plant control, automated car assembly plant, medical, peripheral equipments like laser printers, scanners, automotive and transportation, telecommunication applications, aerospace, internet and multimedia, consumer electronics, defense applications like missile guided system, and miscellaneous applications like railway reservation. This is the basic model of a real-time system. Basically, there is a sensor in which, by which input conditioning unit and input interface and real-time computer and human computer interface. Real-time computer with output interface, output conditioning. Let us see some characteristics of our real-time system. Time constraints, deadline associated with tasks, new context criteria, by safety critical concurrency, distributed and feedback structures, task criticality, custom hardware, reactive, stability and exception handling, safety and reliability. In traditional system, safety and reliability are dependent issues. In real-time systems, safety and reliability are independent issues. Fail-safe state of a system is one which is entered when the system fails, no damage will result. Safety critical system is one which failure causes severe damage. How to achieve high reliability? Steps to achieve high reliability software are error avoidance, error detection, removal, fault tolerance. Hardware fault tolerance, built-in self-test, triple modular readings. Software fault tolerance and version programming and adaptation of TMR technique. It's not very successful in achieving fault tolerance. Recovery block. Checkpointing and rollback. So we can we can do the make the checkpoints and we can roll back the recovery in the process. Types of real-time tasks. Real-time tasks can be classified based on consequences of task missing its deadline. Hard real-time task robot from real-time task video conferencing, soft real-time task URL and non-real-time task event. Now we will see timing constraint. Events in real-time system. An event may be either by a system or its environmental. Based on this, events can be classified into stimulus events, which are generated by environment and act as a system. Response events are usually produced by the system in response to some stimulus events. Classification of time constraints. Performance constraints are imposed on the response of the system. It ensures that the system performs satisfactorily. Each of the performance and behavioral constraints can be further classified into delay constraint, duration constraint, and deadline constraint. Delay constraints captures the minimum time lapse between the occurrence of two events, E1 and E2, where T1 and T2 are the timestamps of E1 and E2 require minimum separation between E1 and E2. Deadline constraint captures the pre-feasible maximum separation between E1 and E2, that is, the second event must follow the first event within the permissible maximum separation. where T1 and T2 are the timestamps of E1 and E2 is the deadline, and delta is the actual separation time between the occurrence of two events. Duration constant specifies the time period over which the event acts. It acts as either minimum or maximum. Timing constants are divided into performance constants and behavior constants. And performance constants are further divided into delay, deadline, and duration constant. And behavior constants are divided into delay, deadline, and duration. In delay, there is RR, SR, and deadline. This is SR and RR. And in delay, it is RS, SS, and deadline is SS, RS. Modeling timing constants. It can serve as a formal specification of a system. Finite state machine. It uses to model traditional system. At any point of time, a system can be any one of the state. State is represented by a circle. A state change is called state transition. A transition from one state to another state is represented by drawing a directed arc from source to destination. Extended finite state machine used to model time constants. It extends FSM by incorporating the actions of setting a timer and the expiry events of the time. SS constant. Model of SS type of deadline constant in which we have wait second digits, max wait second digits, and it's very good. RS constant. Next is model of SR type of deadline constant. Next is RR constants. Next is RTT, real-time task scheduling. So, task is generated when some specific events occurs. Relative deadline and absolute deadline. Absolute deadline of a task is the absolute time value by which the results from a task are expected. The relative deadline is a time interval between the start of the task, response time, task precedence. A task is said to be a precedence and another task if the first task must complete before the second task. Types of real-time tasks. Periodic tasks. Time-driven repeat after a certain fixed time interval repeated by phi, pi, ei, di. Monitoring temperature of a patient in an ICU. A periodic task is when events driven arises at random instance. Task activated upon detecting change in patient's condition. Sporadic task. Sporadic task is recurs at random instant represented by TI, EI, GI, DI. Emergency message sending. Task period. PI. AI arrival time. RI ready time. DI deadline. Minimum separation between the consecutive tasks of a task. Worst case time. RDT scheduling basic concept. Valid schedule. A valid schedule for a set of tasks is one where at most one task is assigned to a processor at a time. No task scheduled before its arrival time and the precedence and resources constraints of all tasks are satisfied. Feasible schedule. A valid schedule is called a feasible schedule only if the tasks meet their respective time constant in a schedule. Proficient scheduler, optimal scheduler, scheduling points, primitive scheduler, utilization. Classification of RTT scheduling algorithm: clock driven, event driven, hybrid event. We will see about these in details. So, clock driven scheduling. It is also scheduling point are determined by timer interrupt, also called a liner scheduler because it's fixed the schedule before the start to run. So in this we have table driven scheduling, pre-computed which task would run when store this schedule in a table at a time. Application program can have own schedule. Cyclic scheduler, yes, popular and extensively used in industry. Simple, efficient, and easy to program, repeats a pre-computed schedule. Pre-computed schedule needs to be stored on only for one major cycle. Major cycle is divided into one or more minor cycle and is called frame. Each task is designed to run in one or more frame. Assignment of task to frame is stored in a schedule table. Frame size should satisfy the following constant: minimum context usage, minimization of table size, satisfaction of task deadline. Hybrid scheduling. In hybrid scheduling, time sliced problem scheduler, primitive scheduling method, ready tasks are held in circular queue, time sliced, event driven scheduler. Overcomes the shortcoming of other types, can handle aperiodic and sporadic tasks more efficiently, less efficient, and deploys complex scheduling algorithm less suitable for desired application. Scheduling points are defined by task completion and task arrival. Foreground and background scheduler. Simplest priority driven scheduler. RTT in an application is run as foreground task. Sporadic, aperiodic, and non-RTT are run as background task. Amongst foreground tasks at every scheduling point, the highest priority task is taken up for scheduling. A background task can run when no one of the foreground is ready. With this, we would stop this topic. Thank you.